Hi, it's Clark on Temptress. Today we're going to do a buy or DIY video. Last video I reviewed this BougeRV device that steps the voltage up coming from your car's alternator so that you can charge a power station in a nice way. See that video if you're interested. Well, let's see if we can build one ourselves. In this video, I'm going to assemble a device that should do the same functionality, and it's going to be really cheap, 25 bucks in major components. In the last video, we did a review of this, the BougeRV Alternator charger. And we went into quite some detail, and I like it. It's a good piece of kit. One thing I forgot to mention is if you had a 24 volt device, like a big truck, a lot of those run 24 volt, or some European vehicles, campers and stuff, this would take 24 volt input and function quite well. So it's not just a 12 volt thing. What this does is it takes a connection that can come right from your car's starter battery. It can watch the voltage, and when the voltage is over the threshold where it knows, hey, the alternator's working, the engine must be running, then it will draw a lot of current from your car battery and take the 12, 13 volts that's coming in, step it up in voltage to something that this could handle, and deliver what amperage this wants, up to 10 amps, into this device. It lets us charge these power stations quite fast while we're driving down the road. I think it's a decent kit to buy, and it's in a nice case, and it has a fan, and it's all pretty, and there's a user interface on your phone, and it's everything you could ask for. And if you didn't mind spending the $200-ish, get one. I like it. I'll probably install this in my truck if I go out adventuring again and decide to bring one of these with me. But if you would like to do this on the cheap, it can be done for like 25 bucks. If you'd like to really understand what's going on and you would like to do an electronic project just because it's fun, honestly, I've always seen things like electronic and software project, engineering projects as kind of like art projects. And like, I used to date an artist, and she would do these art classes. By the way, she hated doing them. It's just something she could do to pay the rent. And she'd go into this place, and these housewives that were bored would come in, and she would set up some flowers or something on a table, and they would all have tea and drinks and giggle. And she would slowly paint that, talking about her process, and they all had easels and they would paint it too. For me, this is art. Electronics are art. And this is a pretty simple art project. So if you want to get started, this would be our version of that. So get yourself a beer or not, because you probably want to think clearly when you're messing with electronics, and play along. This isn't, high art like I think of my bank manager, where there's very sophisticated software doing stuff, but this is where you should start. So we're going to build a device that is going to do the functionality of this device for very little money, and we're going to know how it works. We're going to really understand it. If it ever failed or started acting screwy in the future, we could say, well, it's because of this, and then you fix it. It's kind of nice to understand your world. So if that interests you, or just wanting to watch a guy in a shop do this project interests you, this is the video for you guys. Start out with what this is. In its heart, this is what's called a boost converter. If I search on Amazon or eBay, for the word boost converter, I'm going to find a lot of things like this available. This one consists of a couple components that we can see. It brings in lowish voltage. It cleans them up with these capacitors. It has a microprocessor that switches really, really fast, like 20,000 times a second, and it charges up these coils and makes an electric magnet. So there's a big magnetic field in here. Then it disconnects the charge side and unloads the magnetic field in the output side. And when the magnetic field collapses, it can step up the voltage at the cost of amperage. And it does this really, really, really fast. It has a feedback loop that can watch and say, oh, the voltage is getting a little high, give less power to these, and oh, it's getting a little low, give more power. So it can regulate the output voltage quite accurately. Then it has some more capacitors to clean up the mess it made with the switching. There's a diode there, and I'm sure that is there to make sure you don't hook it up backwards. And that's it. That's the device. We've got two potentiometers here. We just call them pots. What a pot is a variable resistor, and one of these is set up to be a way of telling the control circuitry, this is the maximum of number of amps I want you to put out. Don't put out any more current than that. That's a current limiting device. The other one is saying, this is the voltage I want to be your target voltage. Don't go any higher than that voltage. So we have control over its output voltage and its maximum output current. Pretty cool. Now this device can't move as many watts as this device can. You could guess, it's tiny, it doesn't have a fan. And if you push it near its limits, this device would overheat. It needs to be cooled. Well, these are in our ability to do. We're going to solve the problem that it doesn't move enough heat by having more of them. The ad on Amazon is 4 of these for $25. So I've got 4 of these here. Now, this is actually pretty cool how it's set up. The printed circuit board isn't fiberglass. It's a sheet of aluminum with the surface mount. It's probably an insulator and then the surface mount stuff. But that aluminum is going to dissipate the heat from the parts that get hot quite effectively. But we can do better. For not too much money, I bought this. I bought this mostly because I just didn't want to deal with, and I wanted to look nice in the video. It's a heat sink. It's just a hunk of aluminum. They've machined some beautiful fins in it. And it's of the size where I can attach 4 of these in parallel too. So I'm going to take a break right now. I'm going to open the package. I'm going to attach all 4 of these. It's going to be a minute or two for me because I'm going to use this. This is called thermal glue, also available on Amazon. And it's just glue that can move heat real well. What the heck? Oh, and a spatula. So I'm going to use this thermal glue and glue all 4 of these to the heatsink, and then we're going to come back, wire it up, and start playing with it. I'm back. For you, it just been a second, but it's now 24 hours later. I've used that thermal glue to glue these down to my heatsink, and I'm really happy with the glue. It does take 24 hours to really set up hard, and I wanted it set up hard because I'm going to be messing with this because I'm on camera and, you know, I didn't want one sliding. So let's dive in. I have made this a no solder project. I've got these little spring connectors. They're pretty cool. I've used them before, bought some for this. And in short, you undo this little ratchety thing, slide the wire in, and then just lock it down. And you can release it again. So they're pretty cool. They're better than crimp connectors because you can reuse them and make changes. So test bench means changes. I've actually even used them on temptress. So far they're holding up pretty okay. You know, I wouldn't want to dunk them under salt water, but they're pretty cool. Okay, enough to this. So I got a battery here. I got some very big-ish wire, 10 gauge, because a lot of current's going to flow through these wires. Even though it's short, I wanted to get big-ish wires. Comes into these strips. These have 5 connectors, so 1 in. I'll do that in the middle. And then each of these can get its own connection. And I only have 1 connected. 1 connected to ground and 1 connected to positive. So that's this guy. He's on. I have my multimeter set up here. And the probes are connected to the output side, as well as this cable, which will go to the power supply or the power station. So when we're ready for a load, we plug this to the power station. That will eat up our power, and then we'll get to test. I've currently got this guy dialed for 40 volts, but let me show you how that works. I put my screwdriver into the pot for voltage. That's the one towards the middle on this. And when I adjust it, you can see this move. So the voltage is going up and the voltage is coming down. And I'll dial it in as close as I can to 40 just now. It'll go up to 50, but we're just gonna try here first. The other pot is for the current. That's significant for this project. When I plug this in, it's going to draw power. And of course, it's going to try to draw way more than this guy should safely produce. And we don't want to burn this out, and we don't want to harm it. These are rated to put out 6 amps maximum. So when I plug it in, I'm going to tell this guy, no. I want you to be 3 amps maximum. See, 3, 6, 9, 12. I'll say you can be 3 1/3 amp maximum, more or less. And that way it'll keep this guy a little derated. He can get rid of his heat into the thermal mass of this cooling fin assembly. And they'll all put out their 3 1/3 amps. So in total, they can put out more than 13 amps. This guy will only consume 13 amps. That's his promise to us. I verified that. Actually verified that by hooking him directly to a 50 volt power supply, a big battery, and it only took 13 amps or just under, so we're good there. Why we want to set these current limits on each one of these individually. Oh shoot, I just realized I put this one on backwards. Well, that was stupid of me. It's going to look dumb. The wires are going to cross. I might pry it off later on and re-glue it on. Okay, well, that's what happens when you do things on videos. Back to this. I'll get each one set to 3 amps, so no individual one can go over its limit. So if one were to burn out or become disconnected, or they're just, they just, like the voltages were slightly different, we wouldn't want to overload one and try to take like 10 amps out of one, because that would be the end of it. Okay, let's just do that. So I'll plug it in. This will wake up on its own. I'll set this thing for amps. And it comes up slowly, which is really nice for this. If something goes wrong, I'll just whip this out. So I see 3 amps. Shove my little screwdriver in here and turn it the other way. Loosening, and it's higher for these. So I'll set that for 3.3 amps. So this is getting 120 watts out of one of them. Okay. Let me stop that. And do this down the line. So I'll get back to you when they're all set for 40 volts and they're all set for 3.5 amps, 3.3 amps. Okay, I've done the setup, and also that bad sound for a bit is because I just realized I had my mic pack muted, and I'm going to pick up sound off this, so you've already heard it. Sorry for those few minutes of bad sound. But I did a lot, and I didn't want to re-record. So I went through all of these one by one, set their max current, their current limit to 3.3 amps. I chose to set them all for 40 volts to start with because I wanted some leeway. I didn't want to have the voltage locked so that when I adjusted the amps, maybe the amps weren't free to move because it couldn't adjust the voltage, so I brought it down a bit. Anyway, they're all set for 3.3 amps, so none of them will individually try to put out 3.3, 3.4, 3.5 above that. Then I went back through and I set them all for 50 volts. I found from adjusting the pots, they can all go slightly higher than 50, but the rating is 50, so I'm going to stick with 50. Now I'm going to hook them all up in parallel, hook it to this, and let's see what happens. I'm removing my meter, my voltage sensor, because we now know they have good voltage sensors. And I'm going to hook all of this up. Again, be back with you in a second. Okay, we're all together now. Let's see what happens. By the way, I reversed this one. It was just driving me crazy, and I didn't want to have it ugly, so I pried it off with a screwdriver. It came off pretty easy. Scratched the glue off, put it on with new glue. So this one's a little bit movie. So we're just going to be careful. I've got it hooked up to the battery, so it's charged. Let's set this for voltage so I can find out, just kind of show off here. So shove my probes right in here. I have no room for the probes in there anymore. Do not cross the path. Okay, putting out 50 volts. Great. That bears mentioning. This is 12 volts. You touch 12 volts, your body's got too much resistance. Nothing happens. You touch 50 volts, you're going to know it. Be careful. Okay, here we go. This should just go to town and charge. I'm going to set this for current so I can play. The current is coming up. This ramps itself up slowly. 3, 4. Remember, they're all in parallel. Whoa! And the first fire comes out. All right. Sometimes experiments don't work. Popping, popping, popping. This one didn't seem to. So what probably happened is some kind of feedback, because remember I told you they oscillate real fast, that they can't handle happened, and they got burned out. So this experiment is a failure. But we learn from these things. I thought it would work. I really did. I've done this kind of thing before. I mean, I do it all the time with my two power supplies over here. They're essentially the same thing. Well, don't buy these parts. What I'll do, though, is while I was shopping for these, I found something else. It's almost not a project. It's almost exactly this. And I'll put a link to it in the description, and I'll put a picture up. And what it is again, one of these, but all in one unit, so you don't have to worry about the interaction. Excuse me, a little bit of backward smoke. You get to set the current, you get to set the voltage, but the voltage goes really high, higher than this, but not higher than this can take. So that would allow you to put out the full 1,000 watts into this, where this could only put out like 550. So if you wanted more power, that would be a way to go. It also has a potentiometer for adjusting the minimum voltage when it shuts itself off. Well, that's good. This one essentially says when you drop below 12.8, shut off. So it won't take power out of your car unless your car is running. Well, theoretically, that should do exactly the same thing. And it's in a case, and it has its own cooling, and it only has 2 ins and 2 outs, and great big lugs. And I'm not going to do that one unless this video gets a huge number of comments saying, please do it for me. But that will solve your problem for 80 bucks, 80-ish bucks instead of 220-ish. And move more power. But you have to ask yourself, do you want it to move more power? 600 watts means probably can charge us up in 3 or 4 hours. If I'm camping, that's kind of a drive to the next campground. It's probably okay. Do I really want more current flowing? Do I want to buy bigger wire? Quite possibly not. So you make your choice. I still kind of like this. I'm just going to use that one. Guess that's all for this project. Didn't work. But we know why, and we know not to do it again. At least I do. Thanks for watching. Please subscribe. If you have any questions or comments or want to share your own theories on why it went pop, put them in the description. Other people will read it. We'll all learn from it. Appreciate that. Give me the thumbs up, please. And bye from Clark on Temptress.